Bismillahirrahmanirrahim. Welcome to Pakistan International School Taif. This is Professor Fayad Manjandio. Now, dear students, we are going to start grade 12, second year. Grade 12. You learned chapter number 12 in HSSC 1, means first year. Now, we start chapter number 13. And this is the lecture number 1. And we have to study period number 3 elements in the periodic table. This is the first topic for us. That's called S block and P block elements. S block and P block elements, and the book is National Book Foundation. So you have to buy the new book, latest edition for this book, National Book Foundation. And you have to open the book and you have to write, you have to note, hold the lecture, and you have to revise it. So already I told you in the lower classes that this syllabus from grade 9 to grade 12 is composed very accurately, and there is a relationship between the grade 9, grade 10 and grade 11 and grade 12, the chapters step by step. Step by step. So if you go grade 9 book, there is a full chapter, periodicity, properties of elements, periodic table. You done in grade 9, periodic table, groups and periods, and there are other also properties. So same we have to go here these topics. But the first topic is period number 3 elements we have discussed. So dear students, if you are going to see the second year, and one thing, dear students, in the grade 12, 13 and 14, 2 chapters from inorganic chemistry. 13 and 14 chapters from the inorganic chemistry. 15, 16, 17, 18, 19, 20, organic chemistry. From chapter number 15 to chapter number 20, organic chemistry. Chapter number 21 is a biochemistry. Chapter number 22 is a industrial chemistry. 23rd is environmental chemistry, and 24 is an analytical chemistry. So all chemistries are mixed with the second year. So first 2 chapters, where they are very lengthy, long chapters, 13 and 14, they belong to inorganic chemistry. So in the periodic table, then with the periodic table, so these vertical columns are called groups, and horizontal columns are called periods. Vertical columns in the periodic table are called groups, and these from left to right, horizontal columns, rows, are called periods. So there are 7 periods in the periodic table, and in long form of the periodic table there are 18 groups. Long form of the periodic table there are 18 groups, but if you divide into groups A and B, there are 8 A groups and 8 B groups, so total are 16, but long form there are 18. So here we are going to discuss period 3 elements in the periodic table. Now in the period number 1, just I will tell you, shortest period in the periodic table. Shortest. So you will find only two elements, hydrogen and helium, atomic number 1 and atomic number 2. Period number 1, two elements. In the period number 2, you will find 8 elements starting from lithium, beryllium, then boron, carbon, nitrogen, oxygen, fluorine, neon, like this. Now in the period number 3, elements from sodium, atomic number 11, magnesium, atomic number 12, aluminium, atomic number 13, silicon, atomic number 14, phosphorus, atomic number 15, sulfur, atomic number 16, chlorine, atomic number 17, and the argon, atomic number 18. 1, 2, 3, 4, 5, 6, 7, 8 elements are present in the period number 3. So if you are going to open your book, you can find these elements are present here. So, dear students, this whole periodic table is divided into 4 series, 4 blocks. You done in the grade 11, electronic configuration. So these blocks are S, these series are S, P, D and F. S series elements, P series elements. So here in this chapter number 13, so we will only discuss S and P series elements, S block elements and P block elements. So, dear students, these I have write the periods. So, if you look the periodic table, sodium is present in group number 1A, alkali metals. Down, lithium, sodium, potassium, rubidium, cesium, francesium, like this. So, this is group number 1A element, and this belongs to S block. S series element. Sodium is the S series element, S block. Magnesium belongs to group number 2. Alkaline earth metal, also S series. This is also S. So, two elements, sodium and magnesium, they belong to S series, S block. Reason I will give you why. Starting from aluminium, group number 3A. P block. These are all they are going to present in P series, P block elements. From aluminum to argon, they are P block elements. Now, if you are going to see their electronic configuration, then how we can say this is a P block and how we can say this is a S block? So, sodium, atomic number is 11. So, 1s2, 2s2, 2px1, 2 2py1, 2pz1. Dear students, you done in the first year in the chapter number 2 when we are going to explain the electronic configuration. There are 3 rules are applied. When you are going to fill these sub-energy levels, orbitals, these are the sub-energy levels, orbitals, S for sharp, P for principal, D for diffuse, F for fundamental. These are the sub-energy levels. So you have to follow 3 rules. After principle, Pauli's exclusion principle, and Hund's rule. After principle says that if you are going to arrange the elements in the different sub-energy levels, first you have to put the electron in the lowest energy level, that is a 1s. I am not going to discuss details, we done in grade 11. Lowest energy for the S. And there is one thing, when you put the 2 electrons in the same energy level, then their spin should be different. This is according to Pauli's exclusion principle. Different spin. So this is again S, 2 electrons, so their spin should be different. Dear students, electron configuration is based upon atomic number. The atomic number is 11, so proton must be 11 and electron must be 11. So in the S, maximum electrons 2, in the S, maximum electrons 2, 2 and 2, 4. So there are 3 degenerated orbitals, Px, Py and Pz. These are called degenerate orbitals according to Hund's rule. Actually, P has ability to occupy 6 electrons. Total P has occupied 6 electrons. So each 2. But according to Hund's rule, if you remember, again I am saying grade 11, chapter number 2, you have to first fill with 1, 1, 1, 1. The same spin. 1, 1, 1. Don't put directly 2 here. 1 electron Px, 1 electron to Py, 1 electron to Pz. If there are more, then you can start from here. Now if you calculate 2 and 2, 4, 5, 6, 7, but you have 11. So you have to like this. This one. 1s2, 2s2, 2px2, 2py2, 2pz2, 2 and 2, 4 and 2, 6, 8 and 10. So after completion of P, 1s, 2s, 2p, then 3s. 3s. So dear students, only 1 electron remain behind. So must be present in the 3s with the upward spin. When there is a 1 electron, it must be in upward spin, not downward. So this is an upward spin. 1 electron present in the 3s. Now, why we call S block? Because the last electron present in S. The last electron present in the S sub-energy level. Why we call this third period element? This 3 indicates period. These 3 indicate periods. Principal quantum number. You done grade 11. It's a principal quantum number. N, value of N. This S is an azimuthal quantum number, L. You done this. So this is a 3, indicates period number 3. This S indicates block and this 1 electron indicates group. So sodium present in S series S block, period number 3 with the 1 electron, so group number 1. So we can identify the position of the sodium in the periodic table. It is present in the group number 1, period number 3, and this is the S block. So this is the S block, 1 electron present. Same case here for the magnesium. So magnesium, atomic number 12, you have to add only 1 here. 2 electrons. Should be 2 electrons in the 3. So third period, again S block and 2 electrons, so that's present in the group number 2. So magnesium present in group number 2. Aluminium, atomic number 13, so 3s2, then start 3p. So 1 by 1 electron will be added in the p. In the aluminium, you have 1 electron in the p. In the silicon, 2 electron in the p. In the phosphorus, 3 electron in the p. And in argon, there are 4 electron in the p. 6 electrons. So total 8. Slowly and gradually in the p, sub-energy level electrons are going to be added. So the last electron present in the p, we call them p block elements. So three period elements, sodium, magnesium belong to S block elements, and aluminum to argon, they are called p block elements according to their electronic configuration. Now students, if you open your book, there is a very good achievement for this book. Means side by side, questions are going to be asked. Quick quiz. The question is the electronic configuration of magnesium. The electronic configuration of magnesium. This electronic configuration of magnesium is this one. Write down the electronic configuration of the aluminium. So this is very simple. Very simple question is asked. So 1s, 2s, 2px, 2p, y2, 2p, z2, then 3s, 2 and 3px, 1, 3p, this only. Only this. Period number 3 and block P, because there are 1 electron present and 3 electrons present in the valence shell. This is one valence. This is a valence shell. 3 K shell LM shell. KLM shell 3. So 3 electron present. That's why it's present in group number 3. This is the one question. Second question: which are the two elements, magnesium and aluminium, has the more stable electronic configuration? These are the two elements, magnesium and aluminium. So he said that which has a more stable electronic configuration. Dear students, also if you see grade 9, so if you visit the chapter number I think 4, bonding, filling of orbitals, two rules are applied. One is called duplet rule and other is called octet rule. Duplet rule and octet rule. And S complete by the 2 electrons, P complete by the 6 electrons. D complete by the 10 electrons, and F complete by the 14 electrons. So if you see magnesium, in the last subenergy level S, there are 2 electrons. So its S subshell is complete. S subshell is complete. So it's stable. It is stable. But here in the aluminium, S is complete, but in the P there is a 1 electron. This is the 1 electron in the P. And P required more 5. Px2, Py2, Pz2. So this is a partially filled P, 1 electron only. This is a S completely filled. So this is a more stable due to the S subenergy level is filled with 2 electrons, and here the P subshell, P subenergy level is a partially filled, only contains 1 electron. So this is the less stable. So this is the answer for this question. Now students, we are going to move the periodic properties of elements. Dear students, periodic table is a mirror of the chemistry. If you understand the periodic table, physical and chemical properties you can assess, you can analyze from the periodic table. That's why it's very important, and we can say it's a mirror of the chemistry. So periodic properties of elements. We are talking about the period 3 elements. Period 3 elements means I'm writing here sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. These are the period 3 elements we are going to discuss. So when we are seeing the periodic properties of elements, so we have the very important topics for this explanation for these elements. Number 1, atomic size, atomic radius, atomic radii, atomic size, ionization energy, electronegativity, electron affinity, their melting point, their boiling point, electropositive character, electronegative character. So we have to see for the period number 3 elements. We go from left to right in the periodic table. So one by one we have to explain. Number 1 is atomic radius, atomic size, atomic radii, atomic radius, atomic size of these elements from left to right. If you go in detail, atom is a very small particle, smallest particle, which cannot be seen our naked eyes. So if the very small particle which cannot be seen, so how I measure its size? How I can measure the size? So according to the books, if you visit different books and if you draw the shape of atom element according to Bohr's atomic model. Bohr's atomic model. You will find nucleus in the center, and according to the atomic number there are different shells, orbits, energy levels. So atomic size or atomic radius is defined as distance from the center of the nucleus to the valence shell of an atom. Generally I am saying distance from the center of the nucleus to the valence shell of an atom is called atomic radii, radius. Half of distance also we can say between the two nuclei of atoms. Half of distance or distance from the nucleus to the valence shell of an atom, outermost shell of an atom, is called atomic radius. So dear students, atomic radius generally increases in groups, decreases in periods, because we are talking about periods here. Atomic radius, atomic radii, atomic size of atoms in the periodic table increases generally from top to bottom in the groups as we go down. Hydrogen, lithium, sodium, potassium, or group number 2, beryllium, magnesium, calcium, strontium, barium, like this, increase down the group. And if you go from left to right, from sodium to argon in the period 3 elements, so I have written decreases in periods. Atomic radius generally decreases from left to right in the periods. Reason why? Actually, atomic radius why increases in the groups? So there is one thing, shielding effect, screening effect, shielding effect. As you go down the group, number of shells are going to be increased. Number of shells are going to be increased. In the group number 1 shell only. Group number 2, there are 2 shells. So group number 2. So that's why so dear students, that is why it is going to be increased. But in the periods, no shell is going to be increased. In the sodium, this is the third period, KLM. Only 1 electron is added, same shell. In the magnesium, 1 more electron is added in the same shell. In the aluminium, 1 more electron is added in the same shell. So that is why when we increase in the electron in the same shell, the shells are not going to be increased. So due to this reason, the number of protons we call nuclear size. Nuclear size, number of protons, nuclear charge is going to be increased. So nuclear charge is going to be increased and number of electrons are going to be increased in the same shell. So there is a force of attraction between them. So shells are going to be shrink. So size of the atoms in the period will be decreases, but shielding effect will be same. Shielding effect will be same. No increase in the number of shells. So this is the atomic radii. So atomic radius decreases from left to right in the period as I go from sodium to argon, because nuclear charge, number of protons going to be increased, and number of electrons the same orbit going to be increased. There is the force of attraction. That's why the shrinkness taking place. So generally the atomic radius of the period number 3 element going to be decreases, but the in the top to bottom in the group it is going to be increased. So thank you very much. This first lecture is going to be end. Inshallah we continue this topic, and this is a very long chapter. You have to bring the books and you have to note in the books each and everything. This is very important, and only 2 chapters are for inorganic, chapter number 13 and 14. Thank you very much.